Hi everybody and welcome. Today we're going to be talking about two different ways that we can solve systems of equations. So your goal after watching this video should be able to use elimination or substitution to algebraically solve for a solution of a given set of a system of equations. So today I know that we started off single variable equations with just one seesaw. We're going to be taking a look at a system, and this is basically a visual representation of a system. You take one seesaw and you add a second seesaw. That's all of the concepts of balance, all of the concepts of solving are exactly the same. The only difference is that we're going to be applying it to two instead of one now. So in the situation here, we're looking at two seesaws. If we had equal weight on both sides, again, we would expect, like we've seen so many times before, a pretty good balance. We would see, again, a nice even balance going across, something like that. And if we have two of them, our goal when we're solving systems is to make sure that just like they are evenly across here, we don't want to change that balance. We want to make sure that no matter what we're doing, we keep the balance on both of these the same. So your goal when you're looking through these is, let's say we have like a little kid on the left side over here, and I'll use this so we can actually see it, maybe a slightly smaller example. But if we have, a kid on the left side right here, and then another one over here, and then the same thing for our bottom one. And again, my art is next level, so you are truly blessed that you can see this masterpiece. So two balanced seesaws, and we have one kid on each. So now what happens if, as we're going through, we want to transfer something from one seesaw to the other? So let's say he jumps from here to here. Well, immediately we would see that this seesaw would become unbalanced. So to keep it balanced, we would have to do the same thing on the other side. So he would also have to jump from here to here. And now, sorry that I keep on getting kicked out here. Once we're in this situation, we're going to see that, hey, we have two kids on our seesaw on the bottom, and then an equal amount of zero weight on the seesaw on the top. So theoretically, without wind or anything like that, both of these seesaws would stay balanced. So that's our goal today, is instead of just keeping one seesaw balanced, every move that we make, we have to make sure that both seesaws stay balanced. And that's a challenge, and that's why we're going to do what we're doing today. So getting a little bit more challenging. Eventually, by the end of this week, we might even be seeing three seesaws that we're going to try to keep balanced. But the whole idea does not change. We're just keeping things balanced. That's all we're doing. All right, so a definition to start off here. We are going to be looking at solving systems with substitution first. So you've probably seen this in Algebra 1. And again, just a quick review, that's why we're doing substitution and elimination on the same day. But if we can all have the same way that we go about solving these, we'll be in good shape for when things get a little bit more complicated. So this is when we replace one term with another term of the same value. All that this is saying is that we're keeping equal weight. So if you take one child off the seesaw and you put another on, they have to be of equal weight. Otherwise, that seesaw will not stay balanced. So if we add something like this, if we add two x's on the left and one y on the right, substitution would be, okay, so if 2x equals 8, we could take this same seesaw and we could eliminate the 2x and we could substitute it with 8. And that works because on the right side, we're saying two x's have the same weight as 8. So that's why we can interchange 2x and 8. They're the same weight. It doesn't matter which one is on the seesaw. It'll stay balanced. So first, our steps today, we want to isolate a variable. Second, we're going to substitute for that variable. And then last, combine like terms. So let's go through an example. So number one here. Step one, isolate a variable. Looks like that's already done for us. We don't have to do any solving there. We have a y equals. We could also have an x equals. It wouldn't matter. But as long as you have a variable alone, you've substituted. So, you have it isolated. So now it's time to do what we're talking about and substitute into the other equation. So you have 4x minus 2 times y equals 12, and we are going to interchange our y with something that weighs just as much as y. And if we look up at the top, it says 2 weighs just as much as y. They are equal. So we're going to put in a 2 there. So 4x minus 4 equals 12. Add 4, we'll get 4x equals 16. Divide by 4 to get x equals 4. A lot of people want to circle their answer and say, woohoo, we're done. But remember, a system has 2 answers. So every time you see an x, you need a y. You need both of those. In this case, we don't have to do anything because it's already isolated for us. We have y equals 2. But our goal after every single system is to have an x, to have y, have both of those together. If you will, take a look at number 4 now. In this situation, there might be a little bit of work that you need to do first. So for example, if they do isolate the y for us, they do give us 2 minus 4x. So when you're done, your answer is not y equals 2 minus 4x. You need to take that x value and plug it back in order to solve for the constant term for y. So our solution to a system should be x equals and y equals a number. So we want to make sure that we're simplifying it fully all the way down to the numbers. So just something to keep in mind when you're solving that question. All right, next, elimination. So this is when we transform a system in a way that reduces the number of variables. So the idea is that maybe you have something like 2x plus 4x equals 12, and then, minus 2x plus 7x equals, I don't know, maybe 21. Elimination is the idea is that we do something to this system of 2 equations that makes it so that one of those variables is gone. So in this case, we can add them straight up and straight down by combining like terms. And when we do that, we're going to see, I should have made one of this should be a y, sorry, typo. So we should see y's there. Let me fix that for us. So when we do this, we're going to see 11y equals 33. We've essentially eliminated the x term because we got it to cancel out to 0, so we're happy there. So that's the idea of elimination, is that you do something to the system, whether it's adding, subtracting, multiplying, dividing, something, as long as you're not multiplying by 0, that is going to reduce the number of variables down to 1. And then that helps you to be able to solve. So first, your job is to line up each equation. You need to match like terms. Sorry about that. So matching like terms. Second, we want to combine the equations to eliminate a variable. And then finally solve for the remaining variable. We want to isolate that and get it alone. So quick recap here. Our goal is again to eliminate one of the variables. So if we look at number 1, they already are lined up and straight down for us. I even draw in these little lines to make sure that I'm not missing any negative signs and to make sure that my variables are the same. So I'm just going to add them straight up and straight down. So 4 minus 4 gets us 0x, we're happy. 8 plus 2y gets us 10y, we're happy. And then negative 30 and positive 20, again, be careful with those signs, gets us to negative 10. Divide both of these by 10, we'll get y equals negative 1. And just like before, we can't just circle that and say we're done. Now it's time to go back and to plug in and to solve for our x value. So I'll just take the top equation. You can take the top or the bottom, it doesn't matter. All we're doing is taking that y value and plugging it back in order to solve for x. So we just took that first equation, we replaced y with negative 1, and here we go. Let's get that x term. So 4x equals 28, divide both by 4, x equals 7, and that's our solution. So we have both an x and a y, so now we have a full solution. So again, line these up and straight down, and eliminate. You will see that that will work out very well for you on number 3. On number 2 and number 4, it's going to be a little bit more challenging because when we line these straight up and straight down, it doesn't quite eliminate the variable in our first step. So our job, for example, is if you multiply this one by 7, we'll get 35x plus 7y equals 63. And now when we line up our new two equations straight up and straight down, the -7 and +7 cancel. So before lining them straight up and straight down, maybe you have to do an extra step like multiplying in order to do that. And again, the same thing for number 4. Maybe we should multiply this bottom one by 3. And if we do that, we'll see that we'll have a positive and -9 that will cancel out. So a hint to get you started. I know that it's probably been a little bit since we've seen systems, but two different ways that we can solve equations with substitution and with elimination today. So hopefully that will help. And again, just remember, these are all seesaws. So everything we do to one side of a seesaw, we have to do to the other. And we have to make sure all of our seesaws stay balanced. All right, so finish up these remaining systems here. And if you have any questions or need any help, again, feel free to reach out. And I will see you all in class very soon. Thanks.